Welcome to the Microeconomic Theory 2 course for the class of 2nd April. Today we will continue our discussion about subgame perfect Nash equilibrium, and we'll do certain examples and applications of that concept. Starting with the Stackelberg model. Okay, so the first application of SPNE will be Stackelberg model. Now, we have already done the Stackelberg model, but I just wanted to go over it again to sort of refresh your memories. So in the Stackelberg model, we'll do the two-firm case. So there is a follower, right? There's a leader and a follower, okay? So there is one leader firm and one follower firm. So the leader firm first produces an output Q1, and then follower firm observes leader firm's production and then chooses its own production level Q2. Okay, and the price is given by 12 minus Q1 minus Q2, which is basically same as saying it's 12 minus Q, where Q is the market level production or supply, where Q is Q1 plus Q2. Okay, so this is the demand function, right? Now, so individual Q1 and Q2 can be at max 12, right? Because if it's more than 12, then price becomes 0. So Q can be, so all the relevant quantities is any number between 0 and 12. So Q1 and Q2 are between 0 and 12. At max it can be 12. Okay, each one of them. And the other thing is that assumptions, it's a sort of simplifying assumption, is that production is costless. Basically there is no cost of production. It's just to simplify the case. So it basically means that the marginal cost C naught is 0 for both firms. Okay. So this is the setup. Now this is a sequential move game. Why? Because first player 1, so firm 1 moves, and then firm 2 observes firm 1's movement and then choice, and then firm 2 decides its own production. Okay, so it's a sequential move. It's a game because again payoff, which is the profit of one firm, depends on the choices made by that firm as well as the other firm. Okay, so that's why it's a strategic context. My action affects your payoff and your action affects my payoff. Okay, and so therefore it's a sequential move game. So we can express this sequential move game in a extensive form expression. So extensive form expression of Stackelberg model. So what is the extensive form expression? So remember here, quantities which are strategies are continuous. It's not discrete. Okay, so we'll use the sort of tree format for continuous strategies. So the tree format for continuous strategies is a cone like this, right? So first firm 1 moves, so that's the node for firm 1, and a strategy is a continuous strategy Q1 that goes from 0 to 12. Okay, right? Now for each value of Q1, firm 2 can move. So firm 2 observes, knows exactly what q1 is, and then firm 2 moves. So again, I'm drawing a representative choice. Firm 2's choice is also continuous, right? q2 is also continuous. So again, I have q2, which is from 0 to 12. Okay, right? Now then, after the game ends, what is the payoff? The payoff is the profits. So what is, so but there is no cost, so it's just the revenue. So it's p times q. So what is p? So p is 12 minus q1 minus q2, that's price, times quantity of firm 1. So that gives you revenue of firm 1, which is the payoff of firm 1, because there is no cost. Similarly, cost, the payoff for second firm is 12 minus q1 minus q2 times q2, right? So this is the payoff. So this is what the extensive form expression would look like for Stackelberg, right? So first one chooses Q1, which is a continuous strategy. For each choice of Q1, firm 2 then chooses a Q2, and then the payoffs are realized. Okay. Now this is a game where there are no non-trivial information sets. Why? Because firm 2 observes what firm 1 has chosen. So firm 2 knows exactly where firm 2 is located. Okay, so in this game we can apply backward induction. Okay, so we can start with firm 2's choice decision making first, and then go back and then decide, find out what firm 1 would decide. Okay, so we can apply backward induction. Okay, so let's do that. So suppose there is some q1, let's fix some arbitrary value of q1. So suppose 1 has chosen that as strategy, firm 2 observes that q1. So what is the best thing for firm 2 to do here? So firm 2 observes, and then firm 2 has to decide what to do. Okay, now what is firm 2's payoff? So firm 2's payoff is pi 2. Let me switch back to the white. 12 minus q1 minus q2 times q2. So firm 2 would choose a q2 that would maximize pi 2. Okay, for any given level of q1. So q1 is already observed by the time 2 makes its own decision. Okay, q1 is observable to that firm because it's a sequential move game. Okay, so then that implies, what is the first order condition? If you take the derivative of this expression with respect to q2, you will get 12 minus q1 minus 2q2 equals 0. Okay, from this you would get that q2 equals q2 equals 6 minus q1 by 2, right? So that's the best response function of the second firm. Okay, so this is the optimal decision of the second firm, right? So that we take that into account when we will optimize firm 1's choice, firm 1's decision making. Okay, so firm 1 knows that going forward firm 2 would behave this way. For every whatever q1 that firm 1 chooses, q2 would be 6 minus q1 by 2. Firm 1 knows that because firm 1 knows that firm 2 would optimize and maximize its own profits. Okay, so firm 1 takes that into account. So that's the idea of backward induction. Okay, so let's now use firm 1's profit equation. It's 12 minus q1 minus q2 times q1, but firm 1 now knows, so firm 1 is trying to maximize pi 1 by choosing a q1, but firm 1 knows what q2, how firm 2 will behave for any choice of q1. So let's plug that base response in, 6 minus q1 by 2, right, times q1. So that gives you 6 minus q1 by 2 times q1. Okay, so because it's 12 minus 6 and minus q1 plus q1 by 2, so that's minus q1 by 2. Okay, so then what is the first order condition? Now if you take the derivative of this with respect to q1, you get 6 minus q1 equals 0. That gives you q1 star equals 6. So the firm 1 will produce 6 units. Okay, so what is then q2 star? Q2 star, to get q2 star you have to plug here, so that gives you 3. Okay, so the subgame perfect Nash equilibrium of this game is q1 star is 6 and q2 star is 3. This is the solution. Okay, so this is how you think about this kind of oligopolistic markets in game theoretic setting, especially in the case of Stackelberg. This is this is the extensive form expression that sort of would help you form your ideas about how to think about this kind of games. Okay, so in the next video I'll talk more about this kind of games.